Am I audible?
Yes, sir.
Okay. In the last lecture, we have seen some of the example as far as method of list query is concerned, and we'll continue our journey with a few more examples of a different kind. Most probably, in the last lecture, I'm not sure about it. You have to help me out. That the given example, we did it, or it was likely to be done. The example number 35, fit a straight line trend by the method of least square and estimate the value for 2001. Have we done?
Already done, sir.
Pardon? Your voice is not clear.
It
Yes,
has
Vijay.
already done.
Okay, fine enough. Then we'll shift to the next example. Yes. Now, you may come across some of the example in which these 5-6 different items are being asked of. Following data relate to cells of Park Limited. Data given is in form of year and cells in lakhs. Year is from 2000 to the, it starts from 2000 and it goes up to 2005. Total number of years data set is given as 6. 6 is an even number. Cells, it is in form of lakhs. These are the observation, and you have to keep this thing in mind. You have to collect this information from the example itself. Now the first thing is to be done in this case is fit a straight line trend by the method of least squares and tabulate the trend values. Fine enough. You have to make a table, and in that table you have to tabulate the trend values using method of least squares. Since it is given that method of least square means, again you may be recalling it, y is equal to a plus bx kind of a thing is to be done. Fine enough. The second question is eliminate the trend using additive model. What component of the time series are thus left over? Okay, eliminating the trend using an additive model. This is nothing but y minus yc, short-term fluctuation. So here they ask you for one more column, and that column is short-term fluctuation, y minus yc, right? The third thing, estimate the likely sales for the year of 2006. Okay, that you know it how to do it because we did it in the last few examples. Uh, Estimating for the future, that we can do it. What is the annual increase in sales? Value of B, which is an annual increase if your difference of deviation is not from the half of the year. If your deviation is from somewhere 0.5, then always your increase in the cells is 6 monthly. So to get it annual, you have to multiply it with 2, and to get it monthly, you have to divide it with 6. So question number 4 and 5 can be taken care by simply dividing or multiplying it with something. The sixth question, by what year the company's expected sell would have equaled to its target of 84 lakhs? Look, this is something new, and this is a new parameter to be thought of. Now here sales is given to you, and you have to find the year by which the company may get that sales if everything goes right using trend. That we will see how to calculate it, right? Okay, one after another. First of all, let us give attention to the first question. I am expecting the whole example from you people. What should be the first step to be done? Please. Can anyone throw some light on it?
First, we have to arrange it in a proper column.
Column
Row
wise. Fine enough. Column wise means first of all you just make two different columns. First is year, second is cells. Year is 2000, 2001, 2002, 3, 4, 5 and cells whatever it is. Put it in a column format. Okay. What is the next step to be done?
X.
Taking a deviation.
Taking a deviation means again a column is required and a deviation is to be taken off. Okay. From where you will take a deviation?
2002 and 2003. So it is 2002.5.
Absolutely. It is 2002 and 2003. There are 2 years which are a middle year. You have to make it half. 2000 means you have to get a middle point. So 2002.5. From there you have to take a deviation. Okay, once you take a deviation from 2002.5, then naturally the first deviation will be minus 2.5 because 2000 minus 2002.5 gives you 2 minus 2.5 minus 1.50. Since all of them are is in 0.5, you have to make it double. And your doubled deviation taken from 2005 becomes your x now, right? So x is minus 3, minus 5, minus 1, 1, 3 and 5 and ultimately we'll be able to get that summation of x as 0. Fine enough. What should be the next thing? Naturally, what you require is, because our intention is to get it solved using method of least square. Method of least square is y is equal to a plus bx. And if we can make summation of x as 0, your value of a is summation of y upon n and your value of b is summation of, do you recall it? What is the value of b? Anyone?
4.8.
No. What I am trying to make it, what is the formula of b?
Sigma xy divided by sigma x square.
Summation of x square divided by summation of xy. Okay. Fine, just go ahead. Ultimately, try to get value of a and b and try to get an equation. And focus on speed. Try to make it as soon as you can because this sort of example you did it many a times.
For A, the value is 36 and for B, the value is 4.8.
Okay, let us see. If you just make a sum of this column, summation of x square goes to 70, summation of y is 216, summation of xy is 336. Till here, you may be able to do it, right? Okay. A is nothing but summation of y upon n, so it is 216 divided by 6, which comes to 36. And the value of b is 4.8. So the annual trend equation is given by y is equal to 36 plus 4.8x, where origin is 2002.5. Your x unit is, since it is in half, so x unit is half year, y unit is annual sales in lakh of rupees. Now once you get this equation, you have to make a column as they did it here, trend value. Y is equal to, it's YC, Y calculated, which is equal to A plus BX, where your value of A is 36 and value of B is 4.8. Go on substituting different values of X and get the values, right? So this becomes YC now. As they asked for the short-term fluctuation or eliminating the trend. So naturally here one more column is required, and the title of that column is short-term fluctuation. Short-term fluctuation is Y minus YC. So just make a difference. Now you have two columns, Y and second is YC. Make a difference of that two, that will give you Y minus YC. And if you just make a sum of that column, it goes to 0, right? Okay. Now you have all the answers right. The second question was eliminating the trend. Okay, the eliminating a trend, getting Y minus YC. Sorry. Y minus YC. After eliminating the trend, only cyclic and irregular variations are left. That is what you can say. Since the seasonal variation are absent as the data is in annual form, annual data is given. So this is what a caption, or you can say a claim, you can use it. Whenever you are using Y minus YC, that means short-term fluctuation. Short-term fluctuation always consists of cyclic and irregular variation. Because seasonal variations are absent, this is what you can claim just because of the data set given is in an annual format. The next question was to estimate the sales for the year 2006. For 2006, first thing is to be done is you have to calculate value of X. As we know that we have to take a deviation from 2002.5 and then after you have to multiply it with 2 because X we have taken in a column, you can observe it, you have doubled it. So 2006 minus 2002.5, which is 3.5. If you make it double, it becomes 7. So value of X is 7 for 2006. And in the equation, if you put value of X is equal to 7, then simplifying it, you may get Y for 2006 and cells for the year 2006 as 69.6. The next question is annual increase in cells. Annual increase in cells is nothing but your value of B, but here value of B is your X unit is for the half year because your origin is 2002.5. So naturally, to make it an yearly increase in cell, so naturally you have to multiply it with 2. So 4.8 multiplied by 2 becomes 9.6, and 9.6 is the annual increase in cells. Now, if your annual increase in cells is 9.6, then what can be the monthly increase in cells? Monthly increase in cells is nothing but this 9.6 divided by 12, or you can say it otherwise, your value of B is 6 monthly increase in cells, from which you want a monthly increase in cell. 6 monthly is B and you want monthly, so naturally B is to be divided by 6. So 4.8 multiplied by 6, divided by 6, that will give you a monthly increase in cells, which is 0.8. Right? And the last one, which was little newer for our case, 84 lakh. On which particular year you will get the cells of 84 lakhs. So in an equation, your Y is given to you as 84 and our intention is to get value of X. This is again an equation. If you just simplify this equation, you will get value of X by putting some left hand side and right hand side, value of X as 10. Half years from origin 2002.5. Hence, the target is expected to attain in the year, naturally, it is doubled. So 10 divided by 2, that becomes 5, and you have to add it in the origin. So 2002.5 plus 5, that gives us 2007.5. So in the year 2007.5, company may be able to get the annual sales of rupees 84 lakhs. Is it clear? Is it clear?
Yes, sir.
Yes.
Okay. Your response is so low that I'm not confident that things are okay with you. Fine. Let's see next example. The production of cement by a firm is given below. Here is given, production in tons is given. Starting from 1980, 81, 82, and so on up to it is 88. Calculate the trend values by taking 3-yearly moving average, which is the first case. Again, it is, try to read it again, that you have to get trend values by taking 3-yearly moving average. That is the first case. The second case is also calculate the trend values of the above data by least squared method. So ultimately the intention is to compare two different methods. If you use a 3-yearly moving average method and you are getting a trend values, and if you are using the method of least square and getting the trend values, is there any difference between these two? That is what our intention is. So do it one after another, and I am not going to help you out, as I think all of you should be awake enough and you have to put some energy doing it. Come on, first of all, let us do it. 3-yearly moving average. What should be done to get a 3-yearly moving average? Answers from your side.
First, we have to arrange in a proper column, row
Column.
by.
First is column. First column, year. Second column, production in tons. Fine enough, done it. What is next to be done?
Adding up three numbers by first leaving
3-yearly, three is an odd number. Odd number, so nothing is to be done of. In this case, you don't have to do it twice, as you are likely to do it in 4-year or 6-year. So here things will be little easier. Make a bunch of 3, starting it from the first year, and you have to write the average against the middle year. So 1980, 1981, 1982, the production of this 3 years is to be summed up, and you have to write it against the middle year. The middle year is 1981, so you have to write against 1981. Here you can make 2 columns if you require so, or else you can do it directly. Even direct a trend value can be found of. Here they made 2 different columns. One was for total and second was for average. So here you can make a sum. 4 plus 5 becomes 14. You have to put it against 81. What should be done next?
leaving the first element, we have to add 5 plus 6.
Absolutely. Eliminate the first 5 plus 6. You have to write it against the middle 5, and the total comes to 16. So 16 is against 1982. And do the same up to the last. So you will have a 3-yearly moving total elements. Are you getting these totals? 14, 16, 18, 21, 24, 25, 27. The first is
Yes, sir.
dash, the last is dash.
Yes, sir. Completed.
Fine enough. Once you get that sum, our intention is to get an average. So 3 yearly moving average, or you can say trend values. So whatever is the column of total, divide it with 3, you will get trend value, right? So first is dash, dash will remain dash. 14 divided by 3 becomes 4.67. 16 divided by 3, which is 5.33. 18 divided by 3, which is 6. 21 divided by 3, which is 7. So this is how you will get 3 yearly moving average, or you can say trend values. Hopefully everyone is getting that. Are you getting it?
Yes, sir. Yes.
Everyone.
Yes, sir.
Okay. So this becomes 3 yearly moving average. The first part is taken care of. Now you have to take care of the second part. Second part is the same example is to be done using method of least square. Number 2, method of least square. Manisha Kaur, your mic is disturbing everyone. Okay. Using a method of least square, what should be done?
Just taking a arranging it and then taking a deviation.
Absolutely perfect. Number of observations are 9, so you will have a middle year. Since you have a since number of year is 9, 9 is an odd number, so you will have a middle year there.
1983 and 1984.
1984.
No, no,
So
no, no, no. You will not have two
1983.5.
different years as a middle year.
1984.
You will have a single
Only
year as a middle
1984.
year, which is 1984, right? Absolutely. That is what I was clarifying, that your value of n is an even number, then you will have 2 year as a middle year and you have to take average of those two. If your number of year is odd, then always you will have a single year as a middle year. In this case, your value of n is 9. Since your value of n is 9, which is an odd number, so you will always have a single year as a middle year. In this case, exactly the middle entity is 1984, so you have to take a deviation from 1984. Right? Okay, if you just take a deviation, your value of x becomes 1980 minus 1984 becomes minus 4, 81 minus 84 becomes minus 3, and so on. And ultimately, we will be able to get that summation of x as 0. Fine enough, you made column x. Now, what you may require is xy, and the another column is x squared. You have all the entities in front of you. Just make it simplified and get value of summation of x that you found it as 0, summation of xy, summation of x squared, even summation of y. Try to get all these values. Are you getting the same values?
Yes.
Summation of
Yes,
y
sir.
62, summation of xy is 43, summation of x squared is 66. How many of you are getting the same value? Just raise your hands. Hello?
Yes, sir.
Yes, sir.
How many of you are getting all these values perfectly? Raise your hand. There are only two persons, Vijayata and Dikshita.
No, sir, we have.
Okay, then why don't you respond? You don't
We
have to.
raised our hands.
Okay, okay. January, third one. What others are doing? There might be two different possibilities. One, they may not be getting the answer, and the second possibility is they are getting the results, but they don't know how to raise hand. Is it so? Which is the case? There are only three persons who are getting the same results. Okay. The number increased, went to around 10. Okay. Fine enough. I cannot give much time to this case right now. You can uh, drop your hands now. Let us go forward. Okay, the linear trend line equation is y is equal to a plus bx, and in this case our summation of x is 0, so directly we can get value of a as summation of y upon n, which is 62 upon 9, and which comes to 6.89. Value of b, which is summation of xy upon summation of x squared, which is 43 upon 60, which is 0.72. So your value of y is 6.89 plus 0.72 times x. Our origin is 1984 and your x unit is 1 year. Right? Now you just go on substituting different values of x, so you will get different trend values. Substitute it. X is equal to minus 4, x is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, and you will get different values of y. Put it in a column format. Make one more column in your table itself, and the last column will be trend values yc, which is equal to 6.89 plus 0.72 times x. And the entities against all the years are 4.01 against 1980, so 81 4.73 and so on up to 9.77. Are you getting all these values?
Yes, sir.
How many of you are getting?
Yes, sir.
Yes, sir.
How many of you are getting all these values? Raise your hand. Now I will always love to see how many of you are getting these values. I think only 10, 11 people are away. What all else are doing? Fine enough. Let us shift to the next example now. Below are the figures of production in 1000 tons of a sugar factory. Fit a straight line trend by the method of least square and estimate the trend values. The data set given is in form of 1999 to 2005, total number of years. There are 7. Since this 7 is an odd number, so you will have one full year as a middle year, which is 2002. So you have to take a deviation from 2002, which is exactly middle, so it is easy to get summation of x as 0. Fine enough. Go ahead. Value of n is 7, value of y is 623, summation of x is 0. Now I have to build two different columns, xy and x square. Xy is nothing but multiplication of two columns, x and y.
89 and 2.
Okay. Now we have to substitute all these values in equation. Y is equal to a plus bx. Since we are getting summation of x as 0, so your value of a is summation of y upon n, 623 divided by 7, which comes to 89. Value of b is summation xy upon summation of x square, which is 56 divided by 28, and which comes to 2. So your equation comes to y is equal to 89 plus twice of x. And our origin is 2002, so your x unit is 1 year. Now we have to make another column, and that column would be the trend value yc is equal to 89 plus 2 times x. Substitute different values of x in that case as -3, -2, -1, 0, 1, 2, 3. Simplify it and get all the values, and those values are 83, 85, 87 and so on up to 95. Are all of you getting these values?
Yes, sir.
Sir.
Yes, sir.
Okay. Raise your hand so that I can know that all of you are getting the same values. All of you getting the values?
Yes, sir.
Okay. Now we are shifting to the new level now. Till date or till now, you can say we have came across with different methods. Last week we have seen the method of least square. Do you have any question related to this method? As such, we are going for the next level of computation or the next level of method of least square. So before of that, let me confirm it that you don't have any issue or any questions related to this method when it is linear. Now we want to have one more level of complexity, and that complexity is, instead of linear, it can be quadratic, or you can say parabola. We want to switch over to a new level of complexity. But before of that, I have to make it confirm that you don't have any problem till now. Are all of you ready to have one more level of complexity?
Yes, sir.
Surely.
Yes.
Okay. Dikshita is ready. Is there anyone else who is ready?
Yes,
Nikita is
sir.
ready. Okay. Fine enough. Let's move further. The same sort of an example. The fitting of second degree parabola trend. Till now, the examples in which we have observed that we have always tried to take, or it was literally given to you that they are variable x and variable y are linearly related. Because it always represents a line, so always you were able to get that trend line. But in practice, you may come across many situations where you cannot take that assumption that your variable x and variable y are linearly related. So in that case, you may have to think of a next level, and after a linear, the second thing comes in picture is always a quadratic, or you can say parabolic trend. So in this case, you can say that it is a second degree. The first degree is linear, the second degree is this parabolic. Parabolic or a quadratic, that means the highest power in the equation is 2. So one of the variable may have square format. So in that case, again, you don't have to worry much about it. As such, the standard form of a quadratic equation is a plus bx plus cx squared. And you have to put it against y. So y is equal to a plus bx. That was the last case, right? Linear relation, linearly trend. And in any case, if you just want to shift to a quadratic trend, then the simple, or you can say general formulation or general equation would be y is equal to a plus bx plus cx square. Okay, try to understand it by comparing it with the linear equation. In the linear equation, it was y is equal to a plus bx. In that case, what exactly you did? The exactly thing which we did was something like this: y is equal to a plus bx, and we tried to formulate two different equations out of it. And how? But what you did, what you processed on a standard form an equation to get two different equational parts using data set. The thing which you did was something like this: you inserted summation both the side in the first case. In the second case, you inserted, or you can say implemented, summation of x both the side. This is what you did exactly in the last examples in the linear trend.
Yes, sir.
In
Yes, sir.
this case, since the number of variables, or you can say here the constant values, are 3, a, b and c. Naturally, to get 3 different constant values which in a process gets it converted to variables, naturally 3 equations are required. So a first equation, the standard form of an equation is y is a plus bx plus cx square. Try to get the first equation out of it. Use the same process. The process was simple. The first process is implement summation both the sides. While implementing or applying summation both the sides, y is equal to a plus bx plus cx square will be converted to summation of y, which is equal to a is a constant value which will remain outside, and summation of 1. Summation of 1, and since it is done n times, so it is n. So it is n times a plus b times summation x plus c times summation of x square. Is it clear?
Yes, sir.
Okay. The same process you did in the last example, so there is nothing like rocket science in it. Simply we have implemented summation both the sides. The second equation in the last case, how you found it? In the last case, means in a linear trend, you have implemented summation of x both the sides, right?
Yes, sir.
Do
Sir.
the same. Implement summation both the sides. So in this case, it comes to summation of xy, which is equal to a times summation of x plus b times x was already there, and one more summation of x is inserted, so it becomes summation of x square plus c times summation of x square was already there, and one more summation x is inserted, so it becomes 3 times summation of x cube, and this becomes the second equation. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now we need the third equation. This is different because up to the second equation we were doing it in the last examples because it was linear. Now to get the third equation, you just go on proceeding it in a similar manner. What you did to get the first equation, you implemented summation both the sides. In the second equation, you implemented summation of x both the sides. And in the third case, now implement summation of x square both the sides. Simple. While implementing summation of x square both the side, thing comes to summation of x square y, which is equal to a times summation x square plus b times summation of x cube plus c times summation of x raised to 4. Is that clear to you?
Yes, sir.
Yes, sir.
So here you don't have to mug anything out of it. You don't have to mug it up at all. Simple thing is, to get the first equation, you have to implement summation of x, summation. to get the second equation, you need summation of x to be implemented both the side, and to get the third equation, you have to implement summation of x squared both the side. Right enough? Okay. See further. Now, to get value of a, b, and c, we have to solve these three equations. To get solution of these three equations, I personally think that summation of x by all mean with all the methods available, you should make it 0, or else you'll be in a big trouble. Big trouble in the sense, otherwise to get these three equations solved will be a very tough job. So whenever this method of least square, a second degree parabola, or a quadratic line is to be implemented, it is a sort of a compulsion for all of us to make that summation of x 0. Whenever you try to make this summation of x 0, automatically summation of x cube goes to 0. By all means, you can test it. We'll be testing it in the further process. If you able to get summation of x as 0, automatically summation of x cube will go to 0. When this two element goes to 0, the three equation which we found just now, that can be reduced to this three equation now. Summation of y is n times a plus c times summation of x squared, summation of xy is b times summation of x squared, summation of x square y is a times x square plus c times summation of x is to 4. Now, by further solving this three equation, you will be able to get constant value a, b, and c. From the second equation itself, you can observe that b remains same, summation of xy upon summation of x squared. Once you get this value of b, from equation 1, you can get value of a as summation of y minus c times summation x square upon n. And from the third equation, you may get c as n times summation x square y minus summation of x square multiplied by summation of y upon n times summation of x raised to 4 minus summation of x square whole square. This is what we are getting by simply simplifying the first and the third equation, in which there are two variables now, a and c. If you make a solution of those two, you will get these formulas. So now a is with you, b is with you, and c is with you. In the process of getting a, b, and c, just observe those formulas. You will be able to get that how many different columns are required. Summation of x is required, summation of y is required, summation xy, summation x square y, summation of x squared, summation x cubed, summation of x raised to 4. All these columns are required. So naturally, whenever we are dealing with this second degree parabola, it is going to be little lengthy, or more calculations are needed to be done. Right enough? Are we ready for this sort of examples now?
Yes, sir.
Okay,
Yes, sir.
fine. First of all, let us suppose odd number of years are given. Odd number of years are given. The things are very simple, that you will have a middle year. Middle year means deviation taken would be a full value. You don't have to double it up. So that would be a simpler part. Let us do this example now. Fit a second degree parabolic trend y is equal to a plus bx plus cx squared to the following data. two things are given. One is year, second is production in crores. So first thing is to be done is put it column wise. The first column is year, second column is production. Right enough? From the first column, you can say that number of year given to you are 5. Pi is an odd number. Since it is odd, you will have a middle year, and you can take a deviation from middle year. Middle year is 2011, so deviation is to be taken from 2011. Make a column deviation from 2011. That becomes your x, which is -2, -1, 0, 1, 2. So ultimately, summation of x goes to 0. As we seen it in the previous slide, that what are the things required? We may require a column of xy, x square y, x square itself, x cube, and x raised to 4. Make all the columns. Since all these columns are coming from x or y or both of them, so things are easy for you. Make sum of each of the column. Are you getting the same totals for each of the column? Do it fast as soon as you can. We are running short with time, so make it happen as soon as you can. And let me know once you do it.
Yes, sir.
Done. Very
Yes.
nice. Good. Okay, now since you have all the values which is required, now we have to do some calculation work. As we know that second degree parabola is y is equal to a plus bx plus cx square. The normal equations are implementing summation both the side, and the second equation is implementing summation of x, and the third equation is getting summation of x squared. Simplifying it, you may get the value of b is very simple in that case. So value of b is 16 upon 10, and which comes to 1 upon 6. And from the first and third equation, you will have two different equations consisting two different variables a and c. And if you make a solution of those two equations, you will get the value of a and c. So value of b is 1.6. How many of you are getting value of b as 1.6? Raise your hands. We are running short with time. I am expecting answer from all of you. How many of you are getting value of B as 1.6? What is the value of A and C? Am I audible? Hello?
Yes.
Okay.
Yes, sir.
Then what are the values of A and C? There are two equations which we are getting right now. If you make a solution of these two equations, value of C is 0.71. If you just substitute value of C in one of the two equations, you will get value of A is 5.98. Thus, the second degree parabola trend is given as y is equal to 6 plus 1.6 times x plus 0.71 times x squared, where your origin is 19. Origin is, I think there is a mistake in this case. Origin was 2002, I am not mistaken.
2040, sir.
2011. Deviation was from 2011, so naturally deviation જ્યાંથી લીધું હોય ત્યાં જે હોય એને origin કહેવાય. So in this case, your deviation is taken from 2011, so origin is 2011, your x unit is 1 year. Go on substituting different values of x in the case, in the equation itself, you will get some value. And these values are, if you just substitute x is equal to minus 2 in this case against 2009, simplifying it, you will get 5.64. For 2010, you will get 5.11. For 2011, you will get 6. And so on. And here one more question was given that you have to estimate the value for 2014. 2014, if you just take a deviation, so value of x becomes 3, so y is equal to 6 plus 1.6 times 3. Simplifying it, you may get 17.90. So this 17.19 is the predicted value for 2014. Every one of you getting these values?
Yes, sir.
Yes, sir.
Okay, that's great.
Yes,
So
sir.
this was a sort of a new type of example, and we will proceed it in the next lecture with different kind of examples of a similar kind. And this is what it is called second degree parabola, or they can use the word quadratic trend or whatever it may be, right? In any one of these two, the things will remain same from the beginning. So now I'll take your leave. Thank you. Thank you for your time. Do you have any question
Sir,
regarding this? Yes, please.
can you please share slide of 111 to 115?
again, up to 102 I will share it if I am not mistaken. Whatever we did in the today's lecture, I will be sharing it with you for sure. Right enough? Up to 100,
Okay, sir.
up to 102 slides, I have already shared it in the team. Whatever we did today, that was after 102, that means from 103, and we did it up to 119. So 103 to 119, I'll be sharing it with you in a day, right? Is it okay?
Okay, sir.
Fine enough. Anything else?
No, sir.
No, sir.
Fine enough. Thank you. Thank you for your time.
Thank you, sir.
Thank
Bye and have a good day.